All right, so here's a vector decomposition problem. It's a bit different from several of the ones we've seen before because there's two angles in this thing, right? There's an angle theta, which represents the orientation of the vector f, and there's another angle, in this case phi, that represents the orientation of theta 1 and theta, of e hat 1 and e hat 2. But nonetheless, the approach for solving this thing, or decomposing this vector, is to do what we did before. That is to draw a force triangle, just like we did. So we got the force F on the hypotenuse of the triangle. And then these other two sides are parallel to the e hat 1 and e hat 2 directions. In fact, let's just construct this thing right now. So here I have something starting at the tail of F, moving out in the e hat 2 direction, like so. And then I've got another side of this force triangle moving in the e hat 1 direction, like that. And I arrange them tip to tail so that it's this vector in the e hat 2 direction plus that vector in the e hat 1 direction, which add up to the f. Now what I have to do is I have to identify an angle inside this, hopefully one of the interior angles inside this force triangle. And I think the one that's easiest for me to do is this angle right here, because it's the angle between the force vector f and the e hat 2 direction. So if I were to sort of extend this force vector f right there, it would be this angle right here would be the same as that angle right there. So what's that angle right there? Well, if I extend this all the way out here, we'll notice that since this angle is theta right here, that angle is theta right there. So the angle that I'm looking for, this one right here, that's theta minus phi. Theta minus phi. Do you see how that all worked out? So now that I've identified the angle, then it's a piece of cake putting the rest of the pieces together by this time, I think. So my e hat 1 component, where's the e hat 1? That's this side of the triangle. It's the opposite of theta minus phi. So that's why I have a sign there. Sign means the opposite side from the angle. So we got f sine theta minus phi, and it's a plus because this component in the e hat 1 direction is lined up with the e hat 1 basis vector, so that's a plus there. And then I move on to the other side, the e hat 2, that's this component right there, and that's the adjacent side of the triangle, so therefore I got a cosine, and it's in the positive e hat 2 direction, so I got a plus sign right there. And that's how I came up with the vector decomposition. Boom, and we've got it. We're done.